Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 1, Part 6, and we are starting the third and final section, Matter and Energy. So chemistry studies matter and the changes in matter. So matter is going to have three phases or states, and you can use this term state of matter or phases of matter interchangeably. So solid. This is the state of matter with a definite shape and a definite volume. It's going to have the lowest energy, lowest temperature, and those particles are stuck in relation to each other, and they're just kind of vibrating in place. So my phone is an example of something in the solid state. This book is an example of something in the solid state. The desk is an example of something in the solid state. And a good example for analogy for this is, let's say we have a class of second graders and they are sitting in their desks in neat rows. Liquid is the state of matter where the shape can change, but the volume cannot. So it has medium energy and a medium temperature, and the particles are actually able to flow over each other, but they have to stay connected. So you can pour liquids, but those molecules are going to stay in relation to each other, and they have a little bit more energy than the solid state, and they're moving a little bit faster. So if we have some water, one glass here and one glass here, I can pour this water. Do you see those molecules are flowing over each other? And the volume didn't change. The amount I put in here was the amount that was added to this one, but the shape did change some. So an analogy with that is those second graders, let's say they are in the classroom, but they're moving around, maybe collecting papers or something a little bit. A couple of them are out of their seats moving around, but they're still pretty contained. And then our final state of matter, there is plasma, but we're not going to get into that in chemistry. So our final state of matter is gas. This is a state of matter with variable shape and variable volume. It has a very high amount of energy, high temperature, and those particles are zipping all over the place. They are not connected anymore. They're just moving here and there and everywhere. So they're moving fast enough that the traction to keep them together won't keep them together. And they will move so fast, they will spread out and fill any container you put them in, and they will bump against the walls and hit each other and all that stuff. So if you were to spray, like let's say some Axe body spray, in one part of the room, it's not going to stay there. It's going to fill the whole room. So our second graders, this is when you let them outside. They get outside of the doors and they just burst open and they've spread out into the whole playground and they're zipping around everywhere. That would be our gas state. So let's talk a little bit more about energy. So technically, energy is the ability to cause change or to do work. And doing work has a very specific definition in science. It's force over a length. But we're going to be dealing with the causing change a little bit more than the other part. That one we'll get into in physics more. So kinetic energy is the energy of motion. Those second graders running, my water pouring, the particles of the air moving around, that's all kinetic energy. There is also potential energy, and that is the energy of position or composition. So if I have something that is up high, it has the ability to do work or to cause change if I were to drop it. And the energy of position is its potential energy. The energy of composition has to do with the energy stored within the bonds. So let's talk about gasoline. That has a lot of energy stored in the bonds. And when you create a catalyst, like with a spark or a flame, you will release those bonds and release the energy that was stored between the bonds. And you know that that can give off a lot of heat. And perhaps you remember freshman year talking about energy, kinetic, and potential energy. So chemical energy is a type of potential energy, and it is the energy stored in bonds of molecules. And we talked about chemical energy being in gasoline. There's chemical energy in any of the foods that you eat, and in you, the chemicals stored in you, all over. So let's talk about the whole system. In a system, energy is going to flow from high energy to low energy. So let's talk about this for a second before moving on to the law of conservation of energy. So if you have something up on the hill, and like a rock on the hill, it has high potential energy, and if you give it a little push, it's not going to go back up the hill, it's going to roll down the hill to a position of lower potential energy. So let's talk about the law of conservation of energy. It states energy cannot be created or destroyed, only transformed or transferred. So being transferred, so if I were to push somebody, I will have transferred some of my energy into them, and they will have some kinetic energy while they move forward. Transforming has to do with being transformed from one type of energy to another. So if I have my rock up on the top of a hill, a boulder, and then it starts rolling down the hill, its potential energy is being transformed into kinetic energy, energy of motion. The total amount of energy is the same, it's just changing forms. So let's talk about using and conserving energy on page 29. So looking on page 29, using and conserving energy, sometimes people will get confused because they're like, well, the law of conservation of energy says that there's always the same amount of energy, so how can we use it up, or why do we need to conserve it? So that has to do with the type of energy it is in. So we know that energy can be transformed from one form to another. And with conserving energy and not using energy, we're keeping it in a really useful form and not using it up and having it be transformed into a not so useful form. So let's say you have gasoline in your car, and you burn all the gasoline in your car, and you run out of gas. So that energy didn't go away. It went into mechanical energy to move your car. It went into thermal energy. But good luck trying to get back all of the thermal energy and stuff it in your gas tank and then have your car run. So you'll want to conserve energy so that it is in useful forms. Also, we know when we burn gasoline and any other kind of fossil fuel, the carbon molecules that are locked in those molecules then combine with oxygen and form carbon dioxide, and then that messes up other things. That brings us to measurement and analysis on page 30 and 31. And I would like you to write this down and be able to discuss these things in a class discussion. So examples of measurements in your life, examples of measurements used in healthcare, in hospitals, airport security, measurements used in airport security and specifically nitrogen, air quality and what parts per million is, water quality, some things we're looking at, and parts per million again, and forensic scientists, and a mass spectrometer. So I want you to write these 1, 2, 3, 4, 5, 6 things down, and then be able to discuss them during our class discussion. And that brings us to the end of our Chapter 1 notes. Good job, everybody.